Okay, we're going to look at complex and imaginary numbers. First, we're going to deal with some radicals and how to simplify them. So, the square root of -24. Essentially, there's a rule with square roots that says if you have the square root of two things multiplied, let's say a times b, any two things, I can split this up and say it's the square root of a times the square root of b. And that's the main thing that we're going to be using to simplify any of these problems below. So the square root of -24 I can split up as the square root of -1 times 24. Let's just do that much first. Okay, that -1 is kind of an interesting thing. Basically, you should know that the square root of -1 is defined as I. Okay, so I'm sure you remember that, but that's the other main thing we're going to be using. So as I split this up to the square root of 1 times the square root of 24, that square root of -1 is going to become I. Okay, now the square root of 24, we want to try to break up more if we can. We want to try to simplify that more. And what you're thinking of is what numbers, what perfect squares go into 24. And you want to actually find the largest one. So when I say perfect squares, I mean 1, which is 1 squared, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25. You're looking for these numbers, 36, 49, and so on, that might be a factor of 24, and the largest one at that. So the largest one of these numbers in this list that is a factor of 24 is 4. So I'm going to factor this as 4 times 6, and then I'm going to split it up. Square root of 4 times the square root of 6, and the reason I do that is because I can now take the square root of 4. I know the square root of 4, it's 2. So this is I times 2. We like to write that as 2I root 6. Okay, and that would be the square root of -24 completely simplified in simplest radical form. Okay, what about the square root of -81? Well, same deal. We want to split that up as -1 times 81. That equals -81, and we have two things multiplied, so now I can split it into two different radicals. We have square root of -1 times the square root of 81. Square root of -1 is I, and the square root of 81, we actually know that, that's just 9. We don't like to write I times 9, so we're going to write 9I, and that would be the square root of -81 in simplest radical form. Okay, the square root of -50. For that, we're going to do the same thing. Square root of -1 times square root of 50. The square root of -1 is I. The square root of 50 we want to split up. We want to factor that and find the largest perfect square that goes into it. 25 goes into 50, and that's the largest perfect square that does. So I'm going to go 25 times 2, which will get us 50. And now I can split that up into two radicals. The square root of 25 times the square root of 2. And we do that because we can actually take the square root of 25. It is 5. And so this is 5 times I with the root 2. And that is in simplest radical form. Okay, we also want to look at how we add and subtract some complex numbers. Multiply also. So let's look at this top one. When we're adding things, we're basically doing it in any order we want. So we have 4 plus I plus 2 plus this, I'm going to call this -I, like that. So I can add these in any order I want. I'm going to add the numbers that are like terms. This 4 and this 2 are like, so 4 plus 2 is 6. Plus I plus -I is 0. So in fact, this one, the i's drop out completely, and I just get 6 as my answer. Okay, over here on the right, I'm going to do it in the order that I want as well. I'm going to go 5 minus this 3. 5 minus 3 is 2. And then I'm also going to do -2i minus -5i. Minus negative becomes plus. So this ends up being -2i plus 5i. So -2i plus 5i is plus 3i. And that's my final answer for that. When I'm multiplying, you're going to do this exactly like you were multiplying two binomials. You can treat the I like it's an x as you're starting out here. So 2 times 3 would get me 6. 2 times I would get me 2i. I times 3 would get me 3i. And I times I will get me I squared. So as I combine like terms, I get 6 plus 5i plus I squared. Now I squared is kind of special. I know that I is equal to the square root of -1, and so if I square that, I would have to square both sides, and when I square a square root, it gets rid of the square root, and I'm left with what's on the inside, and in this case -1. So I squared is actually equal to -1. So when I see I squared here, I can actually replace it with -1, and it would look like this, -1 or plus -1, either way. Now I can combine 6 minus 1 and get 5 plus 5i. And so that's the complex number that is the solution to that problem. Okay, on the next problem, I'm doing the distributive property again. I've got 4i times the 2 and 4i times the other I. 4i times 2 is 8i. 4i times I is 4i squared. And as we just talked about, I squared equals -1. So in the place of I squared here, we're going to put -1. And that's going to make that -4. And to write it like we should for a complex number, I'm going to put -4 first plus 8i. And that would be my solution. Because as you're writing a complex number, a number with a constant and an I part, you want to write it a plus bi in a plus bi form. This is called the real part, and this is called the imaginary part.